Hi guys, Dr. B here. So this is our waves lecture. Hopefully you did your Google Doc lab sim and also the POGIL assignment that we did in class. So waves. Probably wondering why we're talking about waves, but hopefully from the assignment you guessed or you realize how important waves are in terms of electrons. Um, we will see in class how that is, and it's going to be the basis for chapter 3, or unit 3, I'm sorry. So waves, so peaks, troughs, all type of stuff. So the tops are the peaks, the bottoms are the troughs, and the distance between two consecutive peaks or two consecutive troughs is a wavelength. So in this lecture, you're going to see a set of equations you're expected to know how to use correctly. I don't want you to memorize them. You can if you want, but I'm more focused on y'all making sure you know how to use them correctly and rearrange them correctly. And know them pretty well, like what the symbols mean, what the units are, etc. So wavelength, like I said, it's the distance between repeating parts of a wave, trough, or peak. So the symbol for wavelength is lambda. That's a Greek lowercase l. The unit for wavelength, the base unit, is meters, and the symbol for that is a lowercase n. Frequency refers to how often a specific part of a wave passes any point. So it's symbolized by nu, and it's the Greek lowercase n. So it's not a v, but it's a lowercase n in Greek. What it means is waves per time or over time. So the unit for frequency is actually hertz, capital H, lowercase z. It's actually 1 over seconds. So this is something to kind of keep in mind whenever you're solving these problems, is that when you see hertz, it's going to be 1 over seconds. So energy is the ability to do work. That's like the official definition. The symbol for energy is capital E, and the unit is joules, not that type of joule, and then capital J is the symbol. So before we talk about the speed of light, make sure you guys keep in mind the relationship between energy and frequency and wavelength from the lab sim. That's important because when you visualizing it and hearing it, you'll be able to you can really picture it in your mind once you actually see it on the sim and when I'm talking about it in class. So when you see the equations, that's where the whole directly or indirectly proportional stuff kind of comes into play. So the speed of light. So the speed of light is constant. It's symbolized by the lowercase c. So the number, so this is a constant, so you're always going to have this, you're going to know this, but it is 3.00 times 10 to the 8 meters per second. Planck's constant, symbolized by lowercase h, is this value right here. 6.626 times 10 to the negative 34 joule seconds. So I'm going to let you in on a little, not secret per se, but if you watch Stranger Things, this number is important for one of the seasons. We'll talk about it in class, but anyway, hope I don't get sued for that. Copyright and all that. Here are the three equations. Again, no need to memorize these, but know how to use them and rearrange them correctly. So energy equals Planck's constant times frequency. Energy equals Planck's constant times the speed of light divided by the wavelength. And then the speed of light, c, equals the wavelength times the frequency. As you can kind of see, in terms of being proportional, energy, for example, energy and frequency. Since h is a constant, it doesn't really affect. So if energy increases, so does frequency. Energy and wavelength, if you increase your energy, think about it with the string, the beads on a string. If you move it faster, the wavelength will get smaller. in terms of the wavelength versus frequency, again, keep in mind, if you are increasing your wavelength, meaning the distance between peaks or troughs, that means that there's not a lot of energy and the frequency of the waves is lower, and vice versa. So keep those relationships in mind. Using these equations will help you out. So I'm expecting 4 main things whenever you're solving problems with formulas like these. I'm expecting you to identify your knowns and unknowns and then write down your formula. The thing is that some students have issues like, I don't know which formula to use. That's why you write down what the symbols are or write down what you have in the problem, and that will tell you which one to pick. You plug in your numbers into your formula, but if you need to convert them, you should do that. If not, it'll mess up your answer. And I'll show you what that means. I'll describe what that means in a few minutes. So for your answer, box, significant figures, and unit. So first problem, a wave has a frequency of 540 hertz and is traveling at 340 meters per second. What is its wavelength? So you can identify these, or you can identify your knowns and unknowns in 2 different ways. I'll do the first one here. So frequency, nu equals 540 hertz. It is traveling at 340 meters per second. So this one doesn't really match in terms of like which formula. So I will let this one slide. But so in this, the wavelength is what we're trying to find. So that is lambda. So it is traveling at 340 meters per second. Now this is obviously not the speed of light, but that's the one we're going to have to pick. So I apologize, this is my bad. So we can just say for this problem, c equals 340 meters per second, but we should know, or I should be aware also that 340 meters per second is not the speed of light. We're going to use that for this particular example. So we then write down our equation. I am trying to solve for wavelength, lambda. So I'm going to divide both sides by the frequency, and I'm going to end up with c over frequency equals wavelength. So remember that hertz is actually 1 over seconds. That's the unit. So it'll be 300, plug in my numbers, 340 meters per second divided by 540 1 over seconds, or hertz, and that's my wavelength. So I'm in meters, and I know that my wavelength is supposed to be in meters, so I can just divide these and I'll be okay. So 340 divided by 540 equals 0.62962 something 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 meters. Sig figs, right? So I have 2 sig figs here, 2 here, so 0.63 meters.